Andrea. So I believe you're using your own machine, yeah.
Interesting. Okay, some of you may know that I'm working on the Emacs Lisp native compiler. So a couple of years ago, I presented a paper. And this is just a quick update on what is going on, and especially what we want to do. So the first question is what we have been doing in the last couple of years. Well, a little bit of development, but especially a lot of debugging, especially in the integration with Emacs, and considerably less in the compiler, interestingly. The good thing is that 28 is close to being released, and native compilation will be in. So I think it's a good moment to have a look to what we are not doing correctly and what we can improve instead of cheering. All right, so one thing that we improved a lot is the value range type propagation engine. So we treat code as SSA internally, and we do prediction on the value of the variables within the full control flow graph. As a consequence, it's very easy to, for instance, compute the return value or type or whatever of a function. So for instance, this is an example. And if you native compile this function and you ask to Emacs 28 what is going to be returned, it will say this function can return nil, float, or integer between 12 and 24. Fine. This example, I mean, it's just another one. This function can return a symbol, big or small, or an integer between -100 and +100. Okay, cool. Last example, not very nice. But yeah, here again, Emacs says this stuff can return an integer, 1 or 2. So here we are assigned to this local variable. Interestingly enough, in this case, we happen to do better than SPCL. So SPCL, in this case, is essentially listing all the possible values that this variable was assigned to, and it's, say, conservative. By the way, I think this information of what a function is returning should end up one day in Control-H, Control-F, so in describe function. I think it's pretty interesting. Okay, so these were things that we do, I think, well, apparently at least. Now something that we are really to improve. So this propagation engine that I showed works well, but has some limitation. And one big limitation is that now it works just with built-in types. So it doesn't have any information of the hierarchy of types that are defined by the user. And so everything that is not built-in is just T. And this has big repercussion in performance. For instance, if we define a structure, then we get indeed defined automatically the accessor function, where we are essentially checking if the object we are trying to access to is of the type we want. And if it's the type we want, then we do the real access that in Emacs Lisp is implemented with an RF in this case. Fine. The problem is that given the propagation type doesn't know about these new types defined by the user, when we have two access consecutively in the code, we cannot say, okay, after the first access, if we are sure that the type is the one we want because an error was not signaled. And so we keep on checking for the type over and over again. And by the way, that's definitely the slow part. It's way slower than accessing. So I think this is a low-hanging fruit, like a low-hanging watermelon that we really have to tackle pretty quickly. Other things, looking a little bit into the code we generate, just to show some assembly. this function is just doing +3. And the sad part of this, except for the number of instructions that is already a little bit suspicious, is that in the end, this is a YARC64 assembly. So it's ARM assembly, is that in the end we do a function call to execute the plus. So here we are not inlining anything. And it's because we know how to inline 1 plus, but not +3. So this is another very simple low-hanging fruit that we had no time to tackle. Other stuff I want to do, I would like to do, if I find the time and the energy, is to add type declaration and type ints. And given now we have a precise source location in the compiler, also use all this system to give better diagnostics and find incoherencies within a code base. That's it.
Thanks. Up next is Benjamin on building a voxel engine, I think. You have a question over there? Yes. Yeah.
The question is if it's GCC that is doing the value type propagation or it's us. It's us. Because GCC does that too late in order to exploit Lisp optimizations that are, say, implemented for Lisp. So we really need to do it earlier. And also there's no way from GCC to get out these informations unless you write a GCC plugin. Yes, exactly. It's all written in Lisp.